I will be explaining what a molecular compound is. There are two kinds of molecular compounds, ionic compounds and covalent compounds. The difference between the two is that ionic compounds include metals and nonmetals. The distinguishment between metals and nonmetals on the periodic table is anything on the left side of this like squiggly line are metals and anything on the right side are nonmetals. So an ionic compound would include one from this side and one from this side, while a covalent compound, which includes two nonmetals, would have two from this side. So we're going to primarily focus on covalent compounds. So one example of a covalent compound would be carbon dioxide. And the reason it's a covalent compound is because both parts of it, carbon and then the oxide, which is oxygen. So carbon is on the nonmetal side along with oxygen. So both parts of the compound are on the nonmetal side, which makes it a covalent compound. So the way we would write it out would be CO2, and the 2 is called a subscript, which means there are 2 oxygen atoms in that thing. So in a covalent compound specifically, the way to, when you write out the actual name of the compound, so not the formula, but the actual name, like carbon dioxide, there would be prefixes to determine what the subscript would be for. So in this case, it would be carbon dioxide and 2, so like matches, so di equals 2. So in covalent compounds, specifically binary covalent compounds, there would be prefixes in front of each atom per se. So for carbon dioxide specifically, there's one carbon atom. There's one carbon atom. So essentially that would be monocarbon, but you wouldn't do that for the first atom. So it'd just be carbon. But then since there are 2 oxygen atoms, you would use dioxide. And the second atom in a covalent compound always ends with "ide." So let's just do a few examples. So the first one we're going to do is diarsenic pentafluoride. So we see that, so since this is a covalent compound, it has the prefixes di and penta. So if we look at the chart, di is, I don't know if you can see it, but di is 2. So 2, let's just mark that. And penta is 5. So now we know arsenic would have 2 and fluoride would have 5. So now if we go to the periodic table, we're going to look for arsenic, and arsenic is As right here. So we're going to write As, and fluoride is F, and that would be fluorine. So F. And since there's a di in front of the arsenic, we know that the subscript would be 2, like I said in this. So the prefix equals the subscript. So the subscript for arsenic would be 2, and the subscript for fluorine, or in this case fluoride in a compound, would be 5. So that would be the formula essentially. So diarsenic pentafluoride equals As2F5. And so now we're gonna flip it around essentially. So you gotta look for C in the periodic table, and C is carbon. So we're gonna write out carbon, and then F is fluorine. But since it's the second part of the compound, it'll be fluoride, because the second part always ends with an "ide." But since there's a subscript, that means there has to be a prefix on the second part. So if we look at the chart, the subscript is 4, and the prefix for 4 is tetra. So the tetra will come in front of the fluoride. I didn't leave enough space, so that would be tetrafluoride. And then the next example would be diboron hexahydride. So we have to look for the prefixes again, and there's di and hexa. So if you look at the chart, di is 2 and hexa is 6. So now we know that the first one would have a subscript of 2 and the second atom would have a subscript of 6. So boron we have to look at on the periodic table, and that's B. So now we know the first one is B2, and on the second one, the hydra part is from hydrogen, and then the ide is because the second part. So we have to look for hydrogen, and that's H. So the second part would be H6. So essentially diboron hexahydride equals B2H6. So the next part, we're gonna solve for like Pi3. So P on the periodic table is phosphorus. So we're gonna write out phosphorus. And the I in the periodic table is iodine. But since it's the second part, we're gonna make it iodide. So iodide. But since there's a subscript right here, it's a 3. And in the chart, a 3 is tri. So 3 is gonna be tri. So the iodide part will become triiodide. So Pi3 equals phosphorus triiodide. And there's gonna be 2 I's next to each other. And then finally, the last one we're gonna do is sulfur dioxide. So we're gonna look for, so sulfur, there's no prefix, so it's just 1 essentially. But if it was the second one, you would have to say monosulfide. But since it's the first one, you can ignore the mono. So just sulfur, and it means 1. The subscript is 1. And the second one, since there's a di, we know that the subscript is 2. So we're gonna look for sulfur on the periodic table, which is S. So S, 1, but we don't have to do that. And the second one, the oxide, is oxygen. So now we're gonna look for oxygen, which is O. And then since the subscript, or since the prefix is 2, that means the subscript is, since the prefix is di, that means the subscript is 2. So now the formula will be SO2. And that's how you solve for covalent compounds. Thank you.